Okay, what are you doing?
Okay, should we discuss in here? Once again, use what you have up there as your evidence, as your talking points. I'm gonna come by here in about 30 seconds or so and get your answers.
Look at it.
210 is way too low. Well, unless if there would be 4 seconds left in this.
We should guess what.
Okay, so see, look at this. So there's 1. Doesn't get you all the way to 3. So it's about 2/3 of the way to 4.
Nice. When you're Austin. That's what I was thinking.
What if we just smack that? That would be so bad.
Okay, let's watch here real quick. I'll go through your estimations here. Okay, and I'm actually going to talk about, after I'm done here, you're listening right now, I'm going to talk about some strategies of how you can think about this a little bit. And there's other ones that we'll do kind of like this one. This has actually a lot to do with rational numbers, which we kind of started yesterday. So here's some estimations. 241, 235, 246, 243, 240, and 243. Okay?
Oh my God.
All right, we'll find out.
It's going to be 242.
Yeah.
Or
It has to be 40.
It has to be 42 or 41 for us to win.
on the dot.
Yeah, on the dot.
Yeah.
You will be.
We have to.
Yeah, it's going to be pretty close because all the answers are pretty close to each other.
We have to be.
You looked it up.
All right, here we go.
Exactly on the dot.
Preston.
So watch, this right here is what we're looking at. Listen, please. This right here.
Are we
Okay,
listening?
just listen. I'm trying to explain it. If you just listen. Okay, this will start to play, and then it'll fast forward, and then it'll slow down at the end again back to normal speed. And then once this stops, it'll be the time over here that we're looking at, okay?
Wow! I feel good.
Oh my goodness.
Oh my gosh.
Oh no, we're over.
When it stops.
Oh no.
When it stops.
Yes.
All right, so that's the answer. Now, it does show 1 second over here, but it's like a split second, so that's when it actually stops. The song is 2 minutes and 47 seconds. Closest group, under by 1 second, was Alex and Cassidy. They get 2:46. Awesome job. Okay, now, real quick, so you guys can see this pretty good here. You had a lot of close guesses, really. Here was my strategy, and I know this is probably more mathematical than maybe you were thinking, but once I explain it, maybe you're like, oh, that's kind of how I was thinking here. So I went with how much time is left compared to how much time is played, and I took that piece and I duplicated it, okay? So I had multiple pieces that are the same length. Okay, and I took those pieces and I put them up to the whole bar just to see, okay, well, how many is each one of those, approximately worth? Okay, so we look at it. Okay, there's the bar. How much was approximately, what's the fractional value for each one of those? Approximately a fourth. I mean, very close. You can see it's just a little bit over a fourth. So the reason I'm saying that is that this bar that's so far played would be just a little either under or over what fractional value? 3/4. Okay, so you can think about it one of two ways. You can say, okay, 3/4 of the song is played, and that's 2 minutes and 6 seconds, so then what would 4/4 be? And that would be your full amount. You can figure that out. I actually went in the opposite way. I try to say, okay, well, if each one of these is technically a fourth, so we have 1/4, 2/4, 3/4, then I'm going to figure out how much each one of those is individually worth. So all I had to do was take 2 minutes and 6 seconds, which would be how many seconds altogether? 2 minutes and 6 seconds.
126.
126. 126 divided by 3. Oopsies. Messed that up. 126 divided by 3. Okay, so approximately 42 seconds per sound chunk. Okay? Now you look, it's 2 minutes and 6 seconds, so if you add 42 seconds to that, that'd be 248. Now it's a little bit under that, so I'd go down a couple seconds, so 246, 247 would be your range. Isn't that pretty crazy how close that actually is to the answer?
Yeah.
Okay? I love this kind of stuff, because you guys, a lot of you listen to your iPod, or you listen to songs all the time, that can all be thought of in terms of fractional values. Okay? And we don't really, it's part of a whole. Fractions are part of a whole. This is part of a whole song. You're trying to figure out how much is the whole song. Okay? And that's a really good mental exercise for estimation there today. Something positive. Go ahead, Alex.
I did a backflip yesterday.
Nice. On trampoline or on ground? Nice. Go ahead.
I'm going to win this weekend.
Cool. Yep.
I'm getting the Rams this weekend.
Awesome.
I have a game today.
Good luck. Go ahead.
I need a new dirt bike tire.
Okay.
It's Thursday.
All right.
I'm getting a new bank account today.
Okay.
What's your last called?
I'm gonna go see my nephew's soccer game.
Cool. Last one.
I get to babysit today.
All right, very good. Okay, we're going to do 2 things here real quick. There's 2 discussion items. The first one, I want you to find someone that has the same shape that you do, whether it's a triangle, circle, or a hexagon, and then just both of you discuss for about 30 seconds what is a rational number. Stand up and discuss.
What are you
Discuss and summarize. Discuss and summarize. Once you're done, tell them thank you and sit back down. Okay, this time, well, first of all, let's just discuss here a little bit. Mitch, what'd you guys say rational number was?
Anything that can be turned into a fraction.
Okay, any number that can be turned into a fraction, which basically is like 99.9% of numbers. Okay, so this is really opening up a box of possibilities for us. Okay, and this is where you see math get a little bit tougher, because you start off at a very young age working only with natural numbers, which would be anything from like 1 to infinity, right? Okay, and then later you introduce whole numbers. What's the whole number thing that's added to that? 0. Okay, and really you don't quite understand this, but you don't start off with, hey, count how many goats are there, and there's 0 goats. You don't start with that. You start with just counting basic things. My daughter, 2.5, I have her count things. I don't say, hey, how many pieces of candy are on the floor? She doesn't say 0. I mean, she doesn't know that yet. And that's a concept that's not there yet, right? So you start off basic. You start off with 1, 2, 3, 4, all the way. That's all your natural numbers, those things that you can count. Okay? Whole numbers are all the numbers that are positive, but then you include 0, which is kind of a higher level of thinking. Okay? What are integers? Okay, negatives and positive whole numbers, also including 0. That's even a higher level of thinking. Okay? So it's almost as if you could think of like, early school, a little bit later, middle school-ish, and then a little bit later middle school. You see what I'm saying? Like, it's levels of difficulty. Okay, now if I place a number in the natural category, it's a natural number, it's also a whole number, an integer, and a rational number. That's important to understand this chart here. Okay? If I place a number in the whole category, no matter what is it? An integer and a rational number also. Now, is it guaranteed to be natural? No. It could be. Okay, but if it's 0, it's not. Okay? If I place a number in the integer category, no matter what is it? An integer and a rational. See what I'm saying? How that chart works? Okay, if I place a number in the rational category, it's only guaranteed to be a rational. It could be all of these, or it could just be a rational number. It just kind of depends upon what you're looking at. Okay? If it's not rational, what is it? Irrational. That'd be numbers like pi, the square root of 2, different numbers that are used for different situations. Okay? Now, the biggest rule for an irrational number is they they go on forever and they never repeat. So I'll give you an idea here. Like 4.3 repeating, even though it's kind of a weird decimal, that's still rational. Okay, because 4.3 repeating, does anyone know that would be as a mixed number with a fraction? 4 1/3, good. Yeah, 4 1/3 or 4 3/9 would be a possibility for that. Great job. Okay? All right. We have a basic understanding of what rational numbers are. We feel good with that for the most part? Okay, we're going to increase the difficulty a little bit today. All right, but before we do that, I want to kind of refresh on our song that we sang yesterday. Okay?
I was singing this all day yesterday.
That's
Yeah,
good.
so was I.
At home, everyone got really annoyed.
That's my goal, is just to annoy
My
you.
brother just started to sing with me.
All right. Okay, listen up, please, real quick. Okay. A true story. I ran into a student the other day. They were taking a math test, and they were in high school. I can't remember which grade they're in now. I lose track. Okay, but they said, like, I used your song in class the other day. So these things, yeah, they're fun to sing the songs, but they're quick. They're easy to memorize. This one's a pretty short song, easy to memorize, and they're there for your use. So let's sing it, but let's also really try to understand what the words mean and what it's there for, okay? So we'll sing it through 2 or 3 times here. Let's not clap. This is kind of a hard one to clap with, okay? Because this doesn't sound good. Okay, sing nice and loud with some gusto here. We'll start at the beginning. We'll sing through it and just be ready to roll, okay? Ready? Just multiply decimals now, multiply decimals. Count them out, count them out. When you're done, when you're done. Move them all down. Move them all down. Here we go. Multiply decimals. Just multiply decimals now. Multiply decimals. Count them out. Count them out. When you're done. When you're done. Move them all down. Move them all down. Here we go. Some gusto. Multiply decimals. Multiply decimals now, multiply decimals. Count them out, count them out. When you're done, when you're done. Move them all down, move them all down. Here we go, ready? Multiply decimals. Beautiful, nice job. I'm sure it'd make Mr. Fruit proud of that one. All right. Okay, great job. Okay, now, once again, yesterday we sang the song. I kind of showed you how it applied. Let's just talk about that here real quick, okay? The part that always throws students off with multiplying decimals, let's just say we have, okay, is technically you do not have to line them up. You can. I'm going to show you how that kind of changes the problem a little bit. That's what I kind of caution with telling you that, because I have students that will do this for multiplication 5 problems in a row, and also they have to add, and then they don't line them up. See what I'm saying there? Addition, subtraction is super easy as long as you line them up. Multiplication, you don't have to, but you do have to count them out. How many decimal places do I have on this problem? 3. So I have 1, 2, 3. So I'm just going to put that over there so I don't forget about it. That's kind of what I do as a habit so I don't forget to move it over when I'm done. Okay? An even better habit is to estimate our answer. Okay, so Aiden, what's a low estimation for this problem? 15. Okay. So no matter what, our answer is going to be above or below 15? Above. Okay? Now if you're going to a store and you're buying some things, that's the only thing you need to know. It's going to be above $15. Do I have at least $15 in my pocket? Okay? Now you might be wondering, like, how does this apply to buying something at a store? Okay? Let's say that you're buying bananas and they charge bananas per pound. You guys didn't know that? Okay? So it's 3.1 pounds. No, actually, let's do that. No, this way. That'd be too expensive. Okay, $3.10 per pound of bananas, and I'm buying 5.75 pounds, right? Okay, so that'd be your multiplication problem in the real world. How much am I buying of the bananas? Okay, now, that'd be kind of, I don't know if that's expensive bananas or not. I don't know. I like bananas, but I don't buy them that much. Okay? True story. Okay, high estimation. What would a high estimation be here? 24. Okay, good. So our answer should land in between 15 and 24. Okay? And quite honestly, the better you get at estimation, you could say this is close to 6, this is close to 3, 6 times 3 is 18, so it should land kind of close to 18, around 15. You'll get better and better with that as you do more of this, okay? All right, so let's go ahead and multiply them here real quick. Pretty basic. We have 5, 7, 5. Have our 0 here. What do we have here for times 5? 15. Then we have 21 plus 1 is 22. 5 times 3, 15 plus 2 is 17. Okay? Alright, we add them up. I'm going kind of fast here, I realize that, but. Okay, now, currently that answer is 17,825. Okay? You'd be surprised. I've seen crazy things in math class. I've seen students leave their answer like that. I'm done. Okay, those bananas are pretty expensive. Right? You get in debt pretty quickly. Okay? Now, the cool thing is, based off of estimation, I should know exactly where my decimal goes. It goes between what two numbers? 7 and the 8. Based on estimation alone, if you forget the entirety of the song, you can use your estimation to figure that out. Okay, it's around 17. Okay, now, use the song here real quick just to show you how this works. Count them out. We have 3. When we're done, move them down. So 1, 2, 3 places. So my answer is 17.825. 17 and 825 thousands. Okay? All right. So if that was money, how much money would that approximately be?
$18.
Yeah, $18 or $17.83 cents. You don't have half a cent. That's impossible.
Are they like mills or whatever? Or like...
There used to be like portions that were like a quarter of something. You know, I mean, they used to be in a different currency, but
Does
they
anyone
made it a
know
lot
what
easier.
those anymore?
I don't know, but they're even considering getting rid of pennies.
Yeah.
Pennies are gonna be a thing of the past here.
Really? In Canada, they don't make pennies anymore because
No.
it costs them.
It costs too much.
50 cents.
It costs them more than they actually like put into the economy. It costs more than a penny to make a penny, so we're losing money on pennies. That makes sense. Okay. All right. Regardless, buy pennies. Okay. We're gonna do a practice here real quick because what we're gonna do today is we're gonna work with rational numbers that are negative and positive. Okay. So the cool thing is the rules we learned for our last our last test was still the rules that are gonna apply to the rational numbers here. Okay. So I want to kind of do some refreshers. We're gonna do 2 games of this, maybe 3. We'll see how it goes. This is called Math Fighter. I'm gonna split you up into 2 teams. Okay. The biggest thing here is this is a fun activity, but I don't want you to not think. Okay? It's kind of a race between 2 teams, but I don't want you to go so fast that you're not thinking. Usually the team that doesn't think does poorly. Let's just say that, okay? So I'm gonna count you off, listen, and then I'm gonna explain how this game works. So you're 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. Okay, now don't come up yet, just remember your number. Remember if you're a 1 or a 2. I'm going to show you how this game works, and then we're going to get a chance to play 1 or 2 rounds. 1 round takes about a minute or so it's pretty easy. Okay. Sorry, hold on, I kind of queued up here. Okay, so this game is a game you can access on your computer. Unfortunately, you can't have it on your iPad because it takes Flash, but if you have a certain way you can get Flash, you can do that. Okay, so I am going to turn on the reflection time because here's what's going to happen. If you answer a question wrong, both groups answer a question wrong, it'll stop the game and I'll be able to talk about what you guys did wrong. So the reflection time will allow you to do that. Okay, I'm going to show you how this works. Okay, we're going to do first players. Now, if the time clicks down, so you want to try to complete the game before the time's up, so don't worry about that too much. The biggest thing is you're going to be one team on this side, another team on this side, and trying to click the correct answer. Okay? So this is a positive 3 because it's a good day. Okay? Alright? Then, hold on. Okay, then you're going to multiply. Now here's the thing, it's a little bit tougher to do in your head, but let's just think 30 times 4 is 120. This is a good day or a bad day? Bad day. Is that pretty close to 120? Yeah. Negative 120? Yeah. So you don't need to know the exact answer on those ones, you just got to estimate a little bit. Okay? Now, let's say this one's a little bit tougher. Okay? Most people will think, oh, it's negative 16. Add the opposite, negative 24 plus negative 8, and this one should be negative 32. Let's say you answer it wrong, though. Okay, what happens is, it takes all their answers away, and then it gives them a free chance to answer the answer correct. Okay, so that if you see that they answer that wrong, then you can answer it right. Okay, and then it breaks the question up again. Keep going. Let's say you both answer it wrong. So this one you say it's 10, and this one you say it's negative 4. That's where it brings in the reflection time. So don't click anything yet. I will stop and talk about why the answer is negative 16. Notice it said it stopped the time too, so we have plenty of time here. Okay, 1 of 2 options. Either one team will technically win by knocking out their opponents, not physically. Do not punch anyone. Okay? So excited, don't do that. Okay? But it'll either knock them out, or when time is up, you're gonna look and see who has the most health left. Whoever has the most health left will be the winner. Okay? This is for fun. Now listen how it's gonna work. It's pretty basic. You'll be in one line with your team. You will answer a question. You get it right or you get it wrong, you will peel to the back of the line. So you're just going to walk around. You're going to get back in line. And the line keeps on moving. So if I'm walking in the line, I'm the next one up. I'm going to answer, and I'm going to go to the back of the line. If I walk up and I technically lose that round, the other person answers, what do? I go to the back of the line because I lost that round. You don't stay up there until you get it right. Okay, you just keep going. So you got to pay attention. Every now and then, we have people who are like, oh, laughing, and all of a sudden they're getting punched in the face because they're not paying attention. Right? Okay? So, I mean, really though, pay attention, just walk through the line. Okay? If you push the board, you'll be fine, but please don't like smack the board. Okay? Just nice touches are fine here. Okay? Now, I say that, like, this is fine. You guys hear that? That's fine. Okay, you don't need to, but like touching it too soft, it won't work. So just a nice touch will be fine. Okay? Alright, so we're going to make our ones go here. So if you're on the one, the left side of the board, two on the right side of the board. Everyone's going to get a chance to go. No matter which order you're going. Okay? Alright, I'm going to get this reset, so hold on a second here. Just wait. Okay. During this time, I should hear a lot of encouragement, not a lot of harping, okay? You guys hear that? We're listening. We're listening. I should hear more encouragement than I do putting people down. Okay, we're not doing any of that. Okay? Okay, if you both answer it wrong, don't click the start again. I'll talk about it and then we'll keep going here, okay? Alright. Here we go. Once I hit first two players, it'll start. So be ready. Okay, after either Cassie or Grace wins, go to the back of the line. Okay? Back of the line. Back of the line.
Oh my goodness.
Just think, estimate. Back of the line.
I just guessed. Let's go back.
Good job. Get a little bit. Yeah. Tomorrow. Yes. And actually, I have your class graded. Yours is done. I just need to finish other classes.
Yeah, so do I.
Wait, did you finish it?
Yeah, me and Danny.
Okay. This is a good practice here. I'm going to remind you how this works. Okay. We'll do a quick 30 seconds activity. Okay. Whether it's jumping jacks or something like that. We'll do that for 30 seconds or so. When I say stop and think, we need to really focus on just refocusing, sit down, and solve the problem. I will pick probably 3 people today to help check. Those 3 people will walk around and help check other people's problems. Okay. Make sure you're showing your steps. Okay. I will say this about rational numbers. This might require more work, not steps. We'll always have the same steps, but more work than we're kind of used to. It's harder to do some of these in your head. Could you still do them in your head if you wanted to? Yes, but once again, you run a caution. I caution you to not, just realize you're going to mess up a little bit more if you do them in your head compared to working them out. Okay, I'm not saying it's impossible, but just be aware of that. Okay. So show your steps. Work out what you need to. Once you're done, I'll come by and check. And then we'll practice 3 or 4 problems here today if we have time. Okay? So everyone go ahead and stand up. Just yourselves, no pencils, anything like that. Okay, we're going to do 2 sets of math jumping jacks to remind you how this works. We're spelling out math, M-A-T-H, and then we're saying math, math, math. That's 1 set. We're doing that twice. Okay, once we do that twice, we'll sit down and solve the problem. Okay? All right, hold on. I'm going to take this off the rest of the face. All right, here we go. Ready? Begin. A, T, H, math, 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 M, A, T, H, math, Okay, try this one. Try this one. So write the problem down first. Like always, see if there's any subtraction you want to take care of, and then from there, go ahead and follow the order of operations. I'll come by and pick some helpers here in a second. I got my helpers here. If you're helping them, make sure you help them. Don't just tell them wrong and walk away.
What did I do wrong?
That's not the right number.
There you go.
Oh, I have 24 more. Oh, yeah.
24, negative 24.
What did I do wrong?
4 times 3.
Yeah, that's right.
Whoa.
Yeah, that's what it is.
I know, you were what?
That's right.
Yeah.
Negative 1.
You were good.
Nice.
I just did 25.
Yeah. Number 15.
Yep.
Oh, until you saw cute mama. What's that?
Make sure that all that work you do is on the side, okay? Kind of your steps. All right, thank you, helpers. Okay, listen closely, please. Go through as a class here real quick. Right now we're just listening. Okay, couple things. Okay, and it's okay to get problems wrong. So some of you made some mistakes. Okay, the same things apply with rational numbers as integers because they're very similar. Okay, so like if we're adding, we can use the song. Same sign, add and keep, different sign, subtract. Okay, we can use that song still with decimals. Okay, and we have to use that here. Okay, the shoes still apply. Now we don't multiply any negative rational numbers in this problem, but if we did, it's still good day or bad day. So I'm not teaching anything brand new. The only thing that's an added element is that because we're using rational numbers, you need to know how to multiply, add, and subtract right now with those numbers, okay? So let's do the multiplication problem here first. Now, this is pretty cool, and I'm going to teach you some mental math exercises throughout the year. A really easy way to do this mentally, okay? I'm going to break this up, and it's easy because this is a whole number, first of all. If these were both decimals, it'd be a lot harder, but this is a whole number. So right now, I'm going to start with just the 4/10. How much money is that? 40 cents. That's 40 cents. Now hold on. Okay, I'm gonna take 40 cents times $3, or 3 times 3. So what if I had 4 piles of 40 cents? Sorry, 3 piles of 40 cents. How much would that equal? $1.20. So watch this real quick. $1.20. Okay, now I'm gonna say $4 times 3, $12. If I add those up, I should have $13.20. Okay, that's a mental exercise you could do to try to do that mentally. Now, if I change this rational number a little bit, I change it to 4.45 and that's to 3.6, that's a lot tougher. Okay, I'm just showing you an example where it's a little bit easier. Does anyone know what property mentally we're using when we use that? Distributive, awesome. We're using the distributive property. We'll learn that some more here later, but I'm going to show you visually how that looks. It's really cool. What we're technically doing is we're taking 3 times 4 plus 0.4. Okay, that's the problem we're doing in our head. The distributive property, we're distributing, right? So we're taking the 3 times the 4, which we did right there, we get 12. We're taking the 3 times the 0.4, which was $1.20. And then in our head, we're adding those together to get $13.20. That is the distributive property. Like, and we'll learn that here later. Why is it called the distributive property? What are we doing? We're distributing. What are we distributing? The 3. We're giving the 3 to everything inside the parentheses. Okay? So I want to show you connections of how we're using math properties if you're doing that mentally. Now, is it okay to work this problem out off to the side? Yes. I encourage it. If this completely confused you, please do it off to the side. Okay? You don't want the silly mistake to be the reason why you get the question wrong. Okay? So, all that being said, we should have 13 and 2/10. Okay, bring everything down. Now here's where you gotta be careful. Now we're using the song. Same or different signs?
Different.
Different, so we're gonna subtract. So off to the side, I'm subtracting 24.5 minus 13 and 2/10. Okay, I get 3, drop my decimal. 1 and 1. I have 11 and 3/10. I saw some of you have this answer, which is a little concerning. Okay, what do I have to do when we're done? Take the sign, keep a higher number. This number is farther away from 0. Even though it's rational, it is farther away from 0 than this one. This one wins the tug of war. So right here, it'd be negative. So my final answer is negative 11 and 3/10. So I'm basically $11.30 in the hole with what I'm talking about. Okay? A problem like this, pretty interesting. Real world situations. Back to the bananas, right? I'm buying 3 pounds of bananas for $4.40 per pound. Or you go the other way. I'm buying 4.4 pounds of bananas that cost $3 a pound, right? How much do the bananas cost me? Or how much money am I? Well, maybe you're selling bananas. I don't know. This is positive. $13.20. I spend this much money at the store on my credit card. I'm now $11.30 in the hole. I mean, there's multiple situations we thought, I don't like you don't have to bring up bananas, but that's a possibility.
I'm hungry now.
Okay, I'm hungry too, always. All right, good job. 1, 2, 3. Okay, everyone stand up. Karate stance. Hit. 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 Karate slice. Hit. 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 Karate crane. Hit. 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 Karate kick. All right, karate 6. Good job. Man, you guys are good. Training a math army. Here we go. Let's try this one. Be careful. Okay? Once again, I'll pick some helpers. I'll try to pick different people, but every now and then I'll pick the same person just on accident. Sorry. I should have looked at things before I came. Anyhow, just double check. Couple things. Right there!
Wait, did you say double check or help check?
Double check. You're not right.
Oh, okay. Yay. Hi. I'm so hungry. Yes, you did. Oh, time. Not wrong. Okay, good.
Did you kind of completely wrong?
No, I didn't.
No! Wait.
Oh, so your name's oh yeah, guys. Oh.
And then, do you see why that is? Okay, just added those numbers together. If you add the opposite, it's going to be 5 plus negative 8.7. I think you thought that 8.77, but 8.7.
Oh my gosh.
But then also that added the opposite. Okay, thank you, helpers. It's a little bit tougher. Doesn't look like it at first glance, but it is. Okay. Alright, take time. Okay, we add the opposite, and once again, I mean, you don't have to, but you've got to be careful with that, because if you don't, you might be a little bit confused on what's actually happening here. I just show you this because I think it makes the problem easier. So I have 3 8/10 times 5 plus the opposite of 8 7/10, which is negative 8 7/10. Okay? I'm technically I should use different parentheses there. Brackets instead. Okay. Alright, so now I still saw the parentheses first. So order of operations still applies to rational numbers. So right there are the same or different signs. Difference, I'm going to subtract. A lot of you subtracted and you got 3 7/10, which is great. But then remember to take the sign of the higher number, it should be negative 3 7/10. Okay? That makes a huge difference. Because now when we multiply, is it a good day or a bad day? It's a bad day, so our answer should be negative. A lot of you have positive answers. That's just showing that gotta be careful when we have subtraction mixed in there. That's why I kind of prefer to get rid of it. Okay? So right here we're multiplying. Okay? The same rules for the multiplying positive rational numbers applies to negative. So we're going to count them out. We have 2 decimals. Okay?
It's 3.7.
It is. Thank you. I did a mistake. Okay? We have 56, 21, 26. Cross off, put a 0. We get 24, 9, 11. And we have 6, 10, 4, 1. Okay. So right now, even if it's negative 1,406, does that answer make sense?
No.
No. Way too, literally too small this time. Way too small. Okay? So now we're going to count the decimals. 2 of them, move it over 2 places. So 1, 2. So go right there. Negative 14 and 6 hundredths. Okay? Alright, you can kind of see what we're building up towards. Right? This is a little bit tougher than just regular integers. Okay? It takes a little bit more patience with that. We're going to finish up with division here next week. We'll look at our test tomorrow. And then after that, we're going to start throwing in some variables with this. So we're kind of just one step at a time. Okay, one step at a time. You guys are doing pretty good with this, though, otherwise. Okay? I think by Monday, we should be able to start dividing here pretty soon. Okay? Monday or Tuesday. Okay? All right, tell someone around you that they're awesome.
You're awesome,
Okay? All right, let's get these picked up, put away. The bell's going to ring in about 30 seconds here, okay?
You're awesome.